Hey everyone, welcome to a problem session. So today I have a really interesting problem uh, about refraction through a prism, and this problem uses also Brewster angle we just talked about a couple of days ago. That's also called Polarization angle. So this problem is like a twofer, a polarization angle problem and um, and a and a prism. And the prism, uh, the regular deviation as well as minimum deviation, they're two different problems. It's kind of really sometimes this JEE exams in India have good problems, and some of them I don't like it, but this one is I would rate it as a good problem. It checks a lot of definitions. Okay. All right, let's see. So it says that if you there's a blue light you shine on, it's a plain polarized light. So so here's a incidence ray, and there's going to be a let's draw the blue thing here. There will be a refracted ray inside here, and then another refracted ray. Now all of these this is the plane of incidence. So if you remember, when you say plane polarized, it can be transverse electric or transverse magnetic. So we can, over here we can say that it says that if you shine this light and it goes through here, but there is no reflection. So like there is no reflection will come out like this, no reflection. Which means this is the only time reflectance is zero is when you shine the light at the Brewster's angle and it's a transverse magnetic. That just will mean transverse magnetic. Polarization, which means magnetic field is maybe coming out, or so the B field in this wave, electromagnetic wave, is coming out of, so going up in the page, out of page, in the page. That's how it's oscillating as it's going through the space. Okay, so that means the electric field is in the plane. So the electric field is oscillating back and forth this way. So electric field is that way. So right away we see that this is A is okay. So A is one of the correct answers. And that took us that this must be I need to know the property of Brewster's angle that this happens. Now let's see if what's the Brewster angle here. So it gives information about, let's try to get some color I can see. So this is the normal one. I'm going to use a really dark color. Normal one. And so this angle is the Brewster angle. So the incidence angle is the Brewster angle. I'm just going to call it angle 1. And then when it refracts over here, we're going to call that angle 2. And when it comes over here, let's do another 90 degree. So this is normal 2, and that's normal to this. This is normal to that. So this angle over here is the angle of incidence for this refraction, and this is the angle of incidence, refraction, angle of refraction. So let's call this theta 4. We'll actually need to work out all of this. Okay, so one question is angle of the prism. So we need to get what that angle is called, angle of prism. So we can call it A, B, and C. Call this point D, call this point F, or E. Let's call this point F. And when you extend this ray backward, we call that point H. So one thing to notice is this angle is same as this angle over here. Let me do red. This angle over here, and this whole angle here is equal to this angle here. If okay, so we you have to practice it, and then you are going to be gonna get better at these angles, walking these angles. So let's walk some angles here, okay, and get some relations so we can actually find what this angle, what the angle over is. So A here, in this AEDF, from AEDF, angle, so angle over here is 90 degrees. Angle over F is 90 degrees. So AEDF is A plus 90 degrees plus angle D. I'm going to omit writing. I'll call angle A, just going to use letter A for it, for brevity, 90 degrees. So all of this must add up to 360 degrees, right? Because you're in a four-sided quadrilateral, right? So you can cancel this guy 180 degrees. So you have a is 180 degrees minus D. So that's one relation we get. So what's D? If you get D, then I can get A, right? What's D? We can get in this triangle EDF. So in EDF triangle, from there we get D plus theta 2 plus theta 3 is 180 degrees. So that just equal. So we can solve for D here and plug in here. So that just takes it to 180 degrees minus 180 degrees minus theta 2 minus theta 3, and so this is just equal to theta 2 plus theta 3. That for A. So we need to figure out angle of refraction here and angle of incidence here. So let's work on what theta 2 will be. Okay, so I can figure out theta 2 if I had figured theta 1. So theta 2 will be, theta 2 can be obtained by, let's call it N for the blue. So, and this N for the red. N for the blue times sine theta 2 equals, the outside is N equals to 1 outside. So 1 times sine theta 1. So if I know theta 1, I can get theta 2, and I can use over here, right? So what's the theta 1? Well, theta 1 is the Brewster's angle because of there was no reflection. So theta 1 is basically theta Brewster, which is arctangent of the ratio of NB to NB, refractive index inside here and outside here, N equals to 1. So this is just a arctangent of a square root of 3. That's given over here for the blue light. For the blue light, for this setup is square root of 3, and so this is like 60 degrees. So theta 1 is 60 degrees. So theta 2, I put it in here, and this is square root of 3 is square root of 3 times so this sine of theta 2 is equal to sine 60 degrees. What is sine 60 degrees? That's the square root of 3 over 2. So over here just that just means sine theta 2 equals to half, which just means theta 2 equals to 30 degrees. So we got theta 2, we need to get theta 3. Now theta 3 can be obtained by looking at what theta 4 would be. Okay, all right, so okay, so theta 3 is the hard one. Okay, so how do we get the theta 3? So when I apply over here, clearly I have to apply there. So let me get a red one. Sine theta 3 will be refractive index times that equals to 1 times sine theta 4. So neither of them are known, right? So we're kind of stuck here. We call this 2, we're going to call this 3, and but the information that's given here is this deviation is 60 degrees. So I can make use of that if I know how to relate to the other angle. Okay, so some people just memorize these things. I tend to just walk through the angle. So over here, if you see this angle is delta, then this angle is 180 degrees minus delta, and then this angle and this angle must add up to 180 degrees. So in that triangle with H and E and F, if you like look at that triangle, this is 180 degrees minus delta, and this one is theta 4 minus theta 3, and this side is theta 1 minus theta 2. Of course theta 1 is known, theta 2 is known. So it gives me a relation theta 4 and theta 3. So theta 1 minus theta 2, theta 1 was 60 degrees, 30 degrees, 16 minus 30. So all this add up is 180 degrees. So let's do 180 degrees minus delta plus 30 degrees plus theta 4 minus theta 3 equals 180 degrees, because we are in a triangle. But this guy cancels out. So delta is this. Delta is just 30 degrees plus theta 4 minus theta 3. And delta is given to be 60 degrees. So this is 60 degrees. So moving over there is theta 4 minus theta 3 equals to 30 degrees. So this is 4. Between 3 and 4, I can solve for theta 3, right? But you can see it's in the sine theta 3 and sine theta 4. So let's just take a sine of, I can bring this on the other side and take a sine on both sides. So theta 3 is, let me just complete this calculation. Okay, so I went ahead and did the calculation out. So first I wrote this as theta 4 equals to theta 3 plus 30 degrees, and then I hit this sine both sides, and the right side expanded sine 33, sine 30, cosine 30, sine 30, and then on the left side I used up this guy, and so I find theta 3 equals to 30 degrees after doing all of that. And theta 2 was also 30 degrees. And then these two together is going to mean A equals to 60 degrees. A 60 degrees. So this B is wrong. Okay, so I can just erase this now and work out the rest. Oh, I just noticed that D is also part of the blue light. So we got B is about theta 4. So here is the theta. So we already know sine theta 4 equals to square root of 3 sine theta 3 will be 30 degrees. And so that will be square root of 3 over 2. Not correct. This is going to be 1 over 2. 1 over 2. So that will make it square root of 3 over 2. And that will make theta 4 equals to 60 degrees. So this is this part is D is correct. So I got A correct, D correct, and B not correct. So to decide about C, I have to look at the red light, this part. So I'm going to now erase this. And okay, so this one is really interesting because we are at the minimum, which means if I reverse the ray, I'll come out the same way. So there's a symmetry here. So if this got to be horizontal. So this is horizontal, and this normal and this normal. So a whole bunch of symmetry you can apply here. So A is the same. So the A is known to be 60 degrees, and so this is theta 2, and this is theta 1, and this is theta 3, and this is theta 4. But these are different numbers than previously. So when symmetry, you apply symmetry, then you are going to you're going to really say theta 1 has to equal theta 4, and theta 2 equals theta 3. So theta 1 equals to theta 4, and theta 2 equals to theta 3. And from here, you can immediately see that A equals to theta 2 plus theta 3. These are general, so it applies here also. So this is 2 theta 2. So theta 2 equals to theta 3 equals to 30 degrees. Okay, so that's that we find. And we want to find angle of refraction, which is theta 4. So what is the theta? No, this one, we want to find refractive index for this. That was the previous problem. We want to find the refractive index for this. So refractive index will come from, applying some kind of either at this point or this point. So if you apply over here, so if this NR sine theta 3 has to be equal to outside's 1 sine theta 4. So you have unknown here and here, which means I need to figure out theta 4, and that's where the theta delta minimum will come from. Okay, in use, so for delta related to all these thetas, we'll get the answer from that. Previously, delta generally delta is equal to theta 4 minus theta 3 plus theta 1 minus theta 2. That was originally I raised over here. So you can see this is just equal to theta 4 plus theta 1 minus theta 2 plus theta 3, and this is just equal to A. And so, and this is equal to each other. So 2 times theta 4 minus A. So if the delta was 30 degrees, so over here you have a 30 degrees equals to 2 times theta 4 minus A was 60 degrees. So if I bring it on the other side, I have so theta 4 equals to 45 degrees. So now I can use this over here and solve for n. R equals to sine 45 degrees divided by sine 30 degrees 1 over square 2, for that 1 over half, and that just gives me square root of 2. So this is correct. Okay, so answer we got was A is correct and D is not correct. B is not correct, B is not correct, C is correct, and then D is correct. So these are the correct answers. Well, this was a lot of angle manipulation, but I like this kind of simple geometry problems, but this is quite combined with a lot of other things that we had to use. We had to use our knowledge of Brewster's angle and type of polarization that will result into no reflection at the Brewster's angle, and what the formula for Brewster's angle is, and then using some kind of symmetry to deal with a minimum deviation. And so I think this is a interesting and good problem to study. Maybe study a couple of times till you master it. Okay, take care and bye.